this is our example number 2. This is the function given 3x minus x cubed. In here, we're going to find the critical points as well as finding out whether such points are the maximum or the minimum values of the function, wherein we're given here with the interval -1 to 3. Okay, according to Fermat's theorem, if the function has a local maximum or minimum, and if the derivative exists, then the derivative at that point is just equal to 0. Okay, so meaning we're going to find the derivative because according to the theorem, it has to be equated to 0. So if I'm going to find the derivative f prime of x of our function, that will be equal to, that's 3, okay, minus 3x squared. Okay, finding the critical number according to Fermat is equating our first derivative to 0. So if I'm going to solve for x, there will be two values. So that would be plus and minus 1. So there are two values when we equate it to 0. But if you will look at our interval, the -1 is there. We also have 1 somewhere in between. So it means that 3 here is an endpoint of our function. So that could be part of our critical number. So if we are going to test, then there will be 3 numbers. Meaning, we're going to substitute our critical numbers to the function given. So again, one of the critical numbers will be x is equal to 3. So finding the values, that would be f of -1. Okay, that will turn out 3 times -1 minus, that's -1 cube. Okay, how much would that be? I think that will be -2. And we will do it on 1 also. That will be 3 times 1 minus, that's 1 raised to the power of 3. I think this is just equal to 2. And finally, if we are going to substitute 3, that will be 3, okay, minus, that would be 3 cube. And this would give us -18. So the points are, of course, it will be -1, -2. The other one is 1 and 2. And finally, we have 3 and -18. By inspection, I think we can tell which is the maximum value and where is the minimum value. It will turn out that the maximum value here will be this one. This will turn out to be the maximum. And here comes our minimum value or the lowest point in our interval. Okay, when we are talking of the function. Actually, we can make use of these points in graphing our function. Okay, so again, our function is f of x is equal to 3x minus x cubed. So how are we going to graph? So if I will have to graph within that given interval, -1 to 3, okay, I can actually plot -1, -2. So I think this will be -1 and -2 is somewhere here. That's -2. We can also have 1 here. Then, of course, we have 2. Okay. And finally, we have 3, negative 18. That must be way down here. Okay, somewhere here. So if I will trace, take note that negative 1, negative 2 is actually somewhere here. Okay, and take note that 1, 2 is a maximum value or point. So actually, we can trace that this could be a local minimum here because it will turn out to be the local maximum at this point. Then eventually it will move downwards to the lowest point here, up to 3, negative 18. Okay, so it will look like this. So actually it can be extended. Okay, it can be extended. This can be extended. But our interval actually is only from negative 1 up to 3. Okay, take note, according to Fermat, that the critical number or points has a slope or has its derivative equal to 0, meaning that's the point where there is a horizontal tangent line or a line whose slope is equal to 0. So if I will trace that, okay, there, I can also have one here below. Okay. So at these 2 points that we have here, okay, as solved using the Fermat's theorem, then these are the 2 points, namely the positive and negative 1. Okay. And of course, 3 here happens to be the end of our function as dictated by our interval. Then of course, expected that this one may not have a horizontal tangent line. So that's the solution in finding for the critical points, as well as telling whether such a point is a maximum or a minimum. And of course, you can make use of those points or information to graph the given function.